What's up, Logic fans? We're hitting our first section on propositional symbolization today. So section 1.3, we're going to learn about negation, conjunction, disjunction, as well as propositional constants and propositional variables. Let's rock. Okay, so let's do a little bit of overview here. We've seen that the single-handed most important concept in logic for us is the notion of inference. What follows from what and why, right? And so if we're going to have a mathematically rigorous, philosophically satisfying account of inference, if we want to develop sort of technical tools for determining what follows from what with mathematical precision, the first thing we need to do is we need to learn how to symbolize statements and develop a formal language in order to carry out those kinds of tasks. So we're jumping to that starting now, and we have this division of labor in the textbook. So today we're just going to cover these guys here, the propositional constants, the propositional variables, negation, tilde, and wedge, okay? And then after that, we have individual units on the material conditional or arrow, the biconditional, tribar. So section 1.5, actually, we're going to cover the arrow because some of the stuff we have to say about ampersand and wedge spill over from this video into section 1.4 also. So conditional arrow in section 1.5, biconditional or tribar in section 1.6, and then we do some grammar devices and how to use parentheses correctly in sections 1.7 and 1.8. So don't be super discouraged if you don't get everything about negation, conjunction, and wedge today, because we're going to do that in section 1.4, and then we're going to be covering all of this stuff, especially when you get into the grammar devices. How to symbolize properly will be a sort of prolonged study for us. And then, of course, after you know how to put all of these symbols together correctly, there's then the further question of what exactly do the symbols mean, and the entirety of chapter 2 is dedicated to that. So it's when we combine all of that together that you're really going to feel like you've got a strong understanding of how all these symbolizations work and what they mean. So be patient with yourself. Okay, so first up for today are propositional constants, perhaps the most important of our symbolic devices for you to get introduced to symbolic logic. So propositional constants are symbols, and we use for these symbols any capital letter of the English alphabet A through Z. We can also add little subscripts, so A sub 1, A sub 2, A sub 10,003. Okay, so we have as many of them as we could possibly need. Same with B, C, D, E, F. Okay, capital letters of the English alphabet. And what these stand for are very, very simply, okay, they just stand for propositions, okay? So let's do an example. The capital letter L here in this example, for instance, would stand for the sentence or the proposition, LeBron is the greatest, okay? Here, the capital letter G, and again, these would be written all by itself, so you might see them this way. You might just see it like this on a page all by itself, okay, just L. And, someone has to tell you, of course, which proposition it's standing for. And so that's indicated here, right? L is standing for the proposition that LeBron is the greatest, okay? And these are propositional constants. So they stand for a proposition, okay? And the idea is that they're constant in the sense that once you assign the meaning, whenever you see L for the rest of the of time, it will always stand for that particular proposition, that LeBron is the greatest. So they're kind of like pi in mathematics. They always stand for the same thing wherever you see them once it's been assigned. So G is going to stand for gravity obeys an inverse square law. So if you see this all by itself, it stands for gravity obeys an inverse square law. If you see P all by itself, that stands for the proposition that grass is purple. Notice that although this is a false proposition, it's symbolized the same way. So propositions, whether true or false, are symbolized with a capital letter of the English alphabet, and we call these propositional constants. Okay, so pretty simple, right? You got these capital letters all by themselves, and they stand for propositions, no problem. Next symbolic device to consider is negation or tilde. So you can write this symbol on your QWERTY keyboard by pressing Shift, and then usually it's the key just to the left of the numeral 1. Okay, and we call that the tilde symbol or negation, and it is read, okay, in ordinary English as it is not the case that. Okay, so this is read, it is not the case that. So for example, okay, without me telling you too much, see if you can figure out what these sentences would mean in ordinary English, again, without my telling you. So we'll go through this together in a second, but pause now and see if you can translate these sentences into ordinary English. Pause now. Okay, hopefully you've had a chance to do this, and it's not that bad, right? A G, of course, by itself just stands for gravity obeys an inverse square law, okay? Not G stands for it is not the case that gravity obeys an inverse square law, okay? So that's how this would be read. Now, 3 would be read, technically, it is not the case that it is not the case that LeBron is the greatest. Some of you might have intuitively translated that as just LeBron is the greatest, as if it were L all by itself. And it's true that those sentences are logically equivalent. So in that sense, it's okay. But we want to be a little bit sort of technical here. And so when you see this, I literally want you to translate it and get in the habit of translating it all the way out. You'll see the reasons for that later, but it's just really good habit to say, okay, this technically is correctly translated. It is not the case that, it is not the case that LeBron is the greatest. Okay, and of course, intuitively, that is logically equivalent to just plain old L all by itself. All right, last one, technically MIT technical point. It is not the case that it is not the case that it is not the case that grass is purple. Okay, which intuitively translated reduces to it is not the case that grass is purple, which is of course a true statement. Okay, so yeah, not that bad, right? So once again, you've got these propositional constants, and you know this is your introduction into symbolic logic. Okay, and then you've got this symbol for negations for symbolizing nots. Okay. All right. One thing I should point out now while we're doing this is just that it's sort of conventional for us to always put nots at the end of sentences. So for example, let me arrange an example here. Here's what I mean by that. Okay, so let's suppose we've got L is LeBron is the greatest, okay, and you're supposed to translate the sentence LeBron is not the greatest. Some students might just sort of say, oh, okay, I'm going to have a sentence G, and it just equals LeBron is not the greatest, okay. By convention, we do not allow this, okay. This is technically, this is incorrect, okay. Don't do this, okay. We do not assign property constants in a way where there's a not embedded into the sentence itself. We always want the not symbolized with the negation, okay? So whenever you see that not, you want to make sure you translate it, you know, sort of positively. So the correct translation would be this, okay? You would want to do it this way, and notice LeBron is the greatest is sort of positive. It doesn't have that not in it, and then you represent the not with the negation, and that's just sort of a convention that we always abide by, and in your logic class your professor will more likely than not always abide by that stricture as well. Okay, pretty easy, right? So you got your propositional constants, you can negate them with the tilde symbol. We can also combine two propositions into a conjunction. So this symbol is the ampersand symbol, and on your QWERTY keyboard, you just hit Shift numeral 7, and that's how you get that symbol. It's called the ampersand symbol, and we roughly read this as just and, okay? So this is translated and our sort of technical term for conjunctions, as we'll see. Again, we're going to be covering all of this over several sections of the text in many videos. This is our technical notion of an and statement is a conjunction. So let's go ahead and do an example. Okay, so notice I switched the propositional constants. They're the same propositions, but I'm using A, B, and C now instead of L, G, and P respectively, and that's just to emphasize we can use any of these, okay? But the meaning is given here, and so translate these sentences into ordinary English, knowing that ampersand stands for and. What do you think these sentences and in symbolic logic notation mean in ordinary English? Pause now. Okay, hopefully you've had a chance to do it, but the first one here would just be translated, LeBron is the greatest and gravity obeys an inverse square law. Okay, now, of course, you may have picked up that 1 and 2 are, logically equivalent. Again, we will explore that notion in chapter 2, but yeah, these are logically equivalent expressions, but, to translate it correctly, this translated would, of course, be translated, gravity obeys an inverse square law, and LeBron is the greatest. So you want to be a little bit sensitive to that, okay? And this one translated is LeBron is the greatest, and grass is purple. And then this one is grass is purple, and gravity obeys an inverse square law, okay? Nothing too bad, right? It's pretty simple, and there's a very, very similar parallel thing we can do with our next symbolic device, which is or. Okay, we use the lowercase v. Sometimes we call it wedge. Okay, for disjunctions, and this is just sort of read as or. Okay, so or you could think of it as either or. Okay, without me giving you too much without giving too much away, just go ahead and try it, okay? So same sentences as before, but now instead of the ampersand, we've got the wedge symbol, so A wedge B, B wedge A V C, sometimes you'll hear your professor say, okay? What do these sentences mean in ordinary English? Pause now. Okay, so hopefully you've got a chance to do this, right? But this just means either LeBron is the greatest or gravity obeys an inverse square law, right? LeBron is the greatest or gravity obeys an inverse square law. Contrastively, 2 says, and of course, they're logically equivalent, as we will later find, but gravity obeys an inverse square law or LeBron is the greatest, either B or A, okay? Either A or C. Either LeBron is the greatest or grass is purple. Either grass is purple or gravity obeys an inverse square law, okay? And that's exactly what those sentences mean, okay? One thing I like to do with students is I like to sometimes sort of give them an alternative way of translating things. So, for example, if you see A all by itself, you could sort of think of that as saying A is true. Contrastively, what you can do is you can say, something like this. You can translate it as saying A is false, okay? And that's just a really, really nice way of being able to think about things. So, for example, if you see A and B, you could think of this statement as saying A is true and B is true. So it's the case that both A and B. It's the case that both A and B are true, okay? Similarly, you could say, think of this as saying either A is true or B is true, okay? But notice when we start combining negations, that can mean things can get a little bit complex. So we're going to spill that into the next video, 1.3b, and we'll pick things up, or we'll pick up the discussion there.